tree diagrams and we're going to work with probability. The first one we'll work with is a coin. What are your options when you have a coin?
Two sides.
You have two sides, and what are they?
Heads, tails.
You either get heads or you get tails, right?
Mm-hmm.
So you either get heads or tails. And assuming the coin is fair, what's the probability of getting heads?
1 out of 2.
Probability of 2 or 0.5, right?
Yeah.
Half or 0.5. I'm just going to represent the two different ways. The same thing, right? Well, what if they ask you, what's the probability of flipping a coin and getting 2 heads in a row?
1 out of 2.
Okay. Well, no, it won't be 1 out of 2. Because what happens, that means you have to get heads and then another heads. And again, remember the probability of getting heads again is another half. So you multiply those values. So the probability of giving heads and then getting heads again is a half times a half, which is a quarter.
Oh.
You only have a 1 in 4 chance of getting heads twice in a row. Okay? What if they say, I want you to get tails 3 times in a row? Well, that's getting tails, and then getting tails, and then getting tails. Now, be aware that the rest of this tree diagram exists. We're just kind of following this route here. That's why I'm focused on it. Well, remember, the probability of getting tails is 0.5.
Mm-hmm.
Probability of getting tails again, because it doesn't depend. Remember, these are independent events, is 0.5. And the probability of getting tails again is 0.5. So that's 0.5 times 0.5 times 0.5, or 0.5 cubed.
Mm-hmm.
What does that equal to? 0.5 to the power of 3. 1.15. 1.25. I said that. Right? Yeah. 1.25. Which is actually the exact same as an 8. Okay? And remember, we could have done that by just multiplying this by half again. Okay? So that's the idea. You're just following one route of getting it 3 in a row. So you just multiply your probabilities by themselves over and over again. And these ones have equal probabilities.
Okay.
So let's think of it like a die. What's the probability of getting 1 twice in a row on a die? Well, on a die, you have many options, right? You have the option of getting a 1, a 2, a 3, 4, 5, or a 6. 6. What's the probability of each of them, though?
1 out of 6.
1 out of 6. And it's identical the whole way through. I don't need to draw these 1, 2, 3, 4, 5, and 6. Just know that it's a 6, right? And in our question, they want you to get 1 how many times?
2 in a row.
2 in a row. So that means you got to get 1 again. Now remember, from there, you could get a 1 and then get 1, 2. There are 6 other options. The second time I roll the dice, I can again get either 1 to 6, any of those numbers. But I still only have a 1 in 6 chance of getting a 1 again. So we multiply those probabilities together. A 1 in 6 chance times a 1 in 6 chance gives you a 1 in 36 chance of twice in a row rolling a 1.
Oh.
So the probability is not that great. It's a pretty low
Okay.
probability that you'll get it twice in a row. Okay?
Okay.
And then the other one we did, we had different values in the probability. So we had to keep those values in mind and follow a specific route. That's why I was showing you the route to it. Okay? Does that kind of make sense for a tree diagram?
Yeah.